Hey everybody, this is Mrs. Henry. We are going to look at the very first lesson in geometry, which is on defined and undefined terms, part 1. Make sure that you have some patty paper with you, maybe a straight edge or a ruler, and of course a pencil. When students came into class, they looked at the warm-up question, which was, if you have this line segment here, what is the location of 1 billion located on this line segment? Now, of course, we got to talk with each other, and I'm just going to kind of quickly go through this. This is just to kind of get you guys to start thinking. But what we determined is that the 0.1 billion would be probably very close to 0 on the line segment. The reason why is because if I have a billion, let me just write over here, 1, 2, 3, 4, 5, 6, it has 9 zeros, and a trillion would have 3 more. So that means that a trillion is 1,000 times larger than a billion. So if I were to think of that in fraction form, then 1 billion is 1/1000th of a trillion. So there would be 1,000 of those little segments in between 0 and a trillion. So 1 billion would be 1/1000th of that line segment. So right about there. So let's take a look at the next page. Why was what we did in the warm-up called a line segment instead of a line? And basically because the segment is just a part of the line. We had the endpoints. There were endpoints there. Now this part right here is pretty much discussion. So it would be whatever you determine with your partner. So a lot of students would say, you know, a line segment has endpoints on each end. It's just a piece of a line. So that's kind of what we put here, a part of a line or a piece of a line. If you were to draw a line, we would then label it H. So to draw a line, and it doesn't matter if you draw it horizontally, vertically, or I'm going to draw it diagonally, we would need to put arrowheads on each end. And the reason why we do that is because that line goes on forever and ever in both directions. So we will designate the name of this as H. Okay, and I can kind of put that anywhere on there. Then we sat with our partners and we talked about how would you define a line? And we realized that that was pretty hard to do. Basically, you would have a lot of points that would connect together in both directions, and it's kind of hard to use a definition of a line without using the word line to begin with. So I know that's a little bit difficult. We kind of skipped this part right here because we talked about a line in length in class, again, something that goes on in either direction. Then we started talking about the facts about the line, that it has infinite length, but it has no height or no width. It is assumed to be straight. It is one-dimensional. So what we talk about when we're talking about dimensions, we're talking about length, width, and height. So one dimension means that it only has length in this case. A line is considered an undefined term. We're going to look at that a little more in the next lesson, meaning that we can describe it, we can attribute characteristics to it, but we really can't define it unless we keep trying to use the word line in the definition. And then again, we know that the line goes on forever in both directions. So a line has infinite length, so any line that we draw needs to have arrowheads on both ends. So we have this purple line and this orange line. And lines can be named by lowercase script letters, sorry about that, or 2 or more points which lie on the line. It says let's use the script lowercase m to name the purple line. So if I were to do that, just put a little m there. use the letters H and R to name the orange line. So I would need to put points H and R anywhere on that line. Okay, I could even put them closer together, further apart. I could even put the R on this side and the H over there. Okay, it doesn't matter. I'll go ahead and put it back because I do like them the way they're given to me. So H and R. And you would either say line M, or in the case of this, the orange one, you would write H and R with a segment on top with the little arrows at each side. That's how our symbols are to name a line. Next thing we're going to do is we're going to talk about planes. So I told you should have some patty paper with you. So look at one sheet of the patty paper. That's usually, a piece of paper is usually how we represent a plane. But imagine if that patty paper went continued in all four directions. It has infinite length and width. So different than a line, it has length and width. And a plane is considered two dimensions because it has those dimensions, length and width. It doesn't have height though. It is also another one of those undefined terms, and it also goes on forever and ever. We just have to name a plane by a single uppercase letter, or we would name it by three non-collinear points. So non-collinear means not on the same line. So you're going to hear collinear and linear throughout geometry this year. Collinear on the same line, non-collinear not on the same line. Let's take a look at 3. Using your patty paper, place your patty paper on top of our drawing here. Put it on top of this and copy through the tracing paper the line KT, include the points on there, and point P. I'm giving you a moment to do that. Okay, now here's where it's going to get a little bit difficult. And I think what I'm going to do is I'm going to pause the video and allow you to read the directions, and you're going to fold and all of that good stuff. Please know that the students in class did have difficulty with the folding of that. I guess following directions was a little bit difficult with it because, first of all, we've never used patty paper before. But after you've copied that, you're going to fold through point P onto line KT. So you should have a fold that looks like so down at the bottom. And then when it says something about coinciding with KT, when you fold it, this point P right here needs to, when you fold it together, point T is going to line up on this line down here. Again, I'm having a hard time trying to explain it without you being physically in front of me. So I think I'm just going to stop and I'm going to let you pause the video, play around with this. It may take you, don't be surprised if it takes you 10 minutes or more to get through all of number 3. So pause the video. Once you've done all of this, come back and check with me when you get to this question right here. That is not a very good drawing. Okay. All right, I'm assuming you've paused the video, you've done all of that, you've seen that you have created parallel lines, you've also are going to be creating some perpendicular lines with this. Don't throw away your patty paper yet, we're not done with it. But if you look at what you folded, you have created another line, WC. You've even created another line, BH. But what is WC in relation to line KT? Well, WC is actually a reflection of segment or line KT. C says work with your partner to describe how the lines you drew on patty paper, the line KT and line WC, lie on the same plane. Well, if you think of your patty paper as a plane, you can see that you have those two parallel lines on there. So if you were able to draw the two parallel lines on the piece of patty paper, that's the same thing as saying that those two lines can be on the same plane. Parallel lines, they lie in the same plane, but they will never intersect each other. And you've probably always heard the definition about parallel lines never intersect. While that's true, we have to specify that they are lying on the same plane. You're going to see here at the end of this unit, or at the end of this section actually, that we have lines that are on different planes and they don't intersect either. So we went through here, continued on with our patty paper, and discovered right angles. So again, I'm going to let you pause the video, follow the instructions, and create your right angle. We know that a right angle is exactly 90 degrees. So when you drew RY, part C says measure the distance between R and the dotted line and then between Y and the dotted line. Now, when you did that, whatever this measurement was here, you're going to see that it matches the measurement here. We call that equidistance. Point R and point Y are both equidistant to the line of reflection. So in this case, when you reflect an object across a line, yes, the corresponding points are the same distance. We're going to say they are equidistant. I feel like I'm spelling that wrong. Pretty sure I may have, but we're going to go with it. Equidistant. Equal distance is what it means. So let's complete the statements. The patty paper is similar to a plane. Okay, think of it as a plane. By reflecting a line across a line of reflections, we created parallel lines. A parallel line, the parallel line I should say, is or is not the same distance from the line of reflection. Well, we saw right here when we measured, that it is the same distance. How is line RY related to the dotted line? Well, RY, segment RY, so here's how you write a segment. There's no arrowheads at it. Segment RY is perpendicular to the dotted line. I know that because that little symbol that looks like a box, this one right here, I'm going to put yellow so you can see it. This little box right here means that we have a right angle, and all right angles are 90 degrees. So if that one is 90 degrees, then so is this angle here. So is this angle here. So is this angle here. They're all 90 degrees. So we've created perpendicular lines. Okay. So perpendicular lines are lines that intersect at right angles. What's different about parallel lines is perpendicular lines do not have to lie on the same plane. They can lie on two separate planes. So think about like a Rubik's Cube or something like that. If you have one of the sides, think of the one of the vertical sides as a vertical line. One of the other horizontal lines, if you were to continue it on, they would intersect each other. Again, I kind of need a visual to be able to help you with that. But if two lines are perpendicular, then any two adjacent angles or angles that are beside each other, they are also right angles. Sorry, someone keeps shutting the outside door and it's making my office door rattle. The last one here is skew lines. I really need to show you a model of what skew lines could look like, because I don't feel like this picture does, it's kind of hard to see in the picture. So do me a favor, come into class, say, Miss Henry, grab that cube and show me skew lines. But skew lines are also lines that do not intersect, but they are on two different planes. So they're not parallel because they're not on the same plane, but they're two lines that will never intersect. So again, come up to me and say, please show me skew lines. So show me skew lines. Okay, again, practice with the patty paper. It's going to take you a little while to do all of that. That is it for this very first lesson. Hope that wasn't too bad. I know it was frustrating not to be able to have me there or a partner there to work with the patty paper, but that's how it goes. So anyway, have a good evening and ask me if you have any questions.